Hi, everybody. This is a solution video for problem 2, homework 5, fall 2025. So this one says reactions for an amorphous blob, very dramatic. So I have object ABC, and it's connected with engineering connections. So we have a pinned connection at A. We have a roller support over at B with an inclined plane of 70 degrees. And we are asked to find horizontal and vertical reactions at A. Okay. I'm going to start with the free body diagram. And so, the shape of this body really doesn't matter, kind of if you draw it as a triangle or whatever. The important thing is that we put a hole there for where we're taking the bolt out. We put a hole here for where we're taking the bolt out. Now, when I teach this early in the semester, I kind of emphasize what we're doing. So I draw these as holes. But as we become more sophisticated, these are going to migrate just to dots like that. So I'll leave it like that for this particular solution. What do I need on my free body diagram? I need my applied force of 100 newtons. And I also need my reaction forces. So the one that may give you trouble is this one right here. So we know that when we have a roller, we can get a reaction, a force reaction that is perpendicular to the rolling surface. Okay, so there is a vector. That is the push force of the roller connection on node. And of course, I can express that in terms of components, and I'll go ahead and break those down. So for my components, I could call those B sub x, B sub y. Okay. And we also, while I'm messing with that vector, we can look back here. That angle of inclination was 70 degrees. And so when I'm looking at this particular vector, what that means is that I'm inclining this here to here, here to here. I'm inclining that at 20 degrees. Right? So this is my right triangle. This is the 70 degrees up here. This one is the 20 degrees here. Kind of good stuff. So if I wanted to express this in terms of like the normal force at B or just vector B is probably the easiest way to say this one. Then I could write something like B sub x is equal to B, and then I can do cosine of 20 degrees adjacent B sub y equals B sine. And we're kind of getting into the point of the course where I probably shouldn't be explaining this so many times, but maybe just one more. So how am I figuring that out? I'm just thinking through the geometry. I'm constructing this little line right there, finding that 70 degrees right there. Therefore, this one is the 20 degrees right there. Okay, and that is consistent with what we just did right there. Okay, so be real careful about making sure that that component, that resultant force B is perpendicular. We also need reactions over at A, and the PINNED, pinned connection, that can give me a horizontal and a vertical. And the vertical one, we already know that it's going to be downward. Do you see that? The vertical one, we already know that it's going to be downward. And so I know that my A sub y is going to be the same as my B sub y, right? One is up, one is down. And for this horizontal one, I don't 100% know which way it's going to go yet. So my load 100 is pointing rightwards, B sub x is leftwards. But I also have a potential for a horizontal one down here. So I'm going to assume that it's going to oppose the direction of the load. So I'm going to assume it's leftwards and work with that. So I've got my three unknowns. My unknowns are AX, AY, vector B. BX and BY are just components of B, so I don't count those as separate unknowns. And my equations of equilibrium, I need 3 to solve this. So I'm going to do my summation of forces in the x direction equals 0, summation of forces in the y direction equals 0, and my summation of moments about some z-axis is equal to 0. So those are my equations that I'm going to use here. All right, the other thing about this problem that's kind of interesting is that I didn't give you any specific lengths. And so I have, I have a certain length LBC up here. It's not given. I have a certain length LAC, but I do give you a triangle like this. And that triangle has ratios of 4 to 7. So there's kind of two different ways that you can approach this. So I think probably the most common would be that people would figure out this hypotenuse and say 7 squared plus 4 squared, and then express the components in terms of that. But I'm going to take a different tact. I'm just going to hold as my unknown. I'm just going to make this one my unknown. So I'll make this one LAC. So that's some length. I don't know what it is. But whatever that is, if I divide by 4 and multiply by 7, I'll get this other length. Okay? So this is 7/4 times LAC. These ratios can be a big saver. All right, I'm going to just remove that one. I don't think I'm going to need that information anymore to solve the problem. So I think I'm ready to get going. Let's go ahead and figure out how we can solve one of the unknowns. So I don't have any force summation equations that will get me to the answer quickly. Remember, these are my weapons of choice right up here. I don't have any of these that are going to get there quickly for force summation. So I'm thinking moment summation is going to be the better way to go. So let's do a moment summation. And we need to figure out what axis we're summing moments about. And to me, this one is a no-brainer. I'm going to pick A. And the reason why I'm going to pick A right here, so some moments about A, is because I've got two unknowns through A. So if I sum moments there, I'll be able to solve for B directly. That'll be the fastest way to work through the solution. Okay, let's go ahead and do it. I'm going to do counterclockwise positive. So my first term, so I have 100 newtons, moment arm LAC, and that sign is negative clockwise. Next term, B cosine 20 degrees. I'm dealing with this force here. Its moment arm is LAC with respect to rotation about A. And its sign is positive counterclockwise. Last term, I'm going to do B sub Y. So I'll write that out as B sine 20. Okay, and its moment arm is 7/4 LAC. And its sign, so that force, B sub Y, when viewed in isolation, tends to rotate the body counterclockwise or positive about A. All right. As we can see here, we're ready to solve this equation, and that cancels out. That's nice. So now I've got minus 100 newtons plus B, factor out, cosine 20 degrees plus sine 20 degrees times 7/4 equals 0. And I think I'm ready just to do my calculator operation for this. Okay, so I'm going to start with 7 divided by 4, multiply by the sine of 20, add the cosine of 20, okay? And that number, 1.53, is the stuff in the brackets. I'm going to do x minus 1 to put it in the denominator of the right side of the equation, and then multiply by positive 100, what's going to be in the numerator of the right side of the equation. And that's going to give me my answer for B, 65.01, 65.01 newtons. And for a final answer, we would lop that down to 65.0. So B is solved. Now I'm ready to do the other two. I think maybe summation of forces in the y direction will be the next easiest to do. So summation of forces in the y direction is equal to 0. So downward I have a sub y. Upward I have b sub y, which is equal to b sine 20 degrees. And I can plug b in. It's already in my calculator. So let's pull up the calculator. Okay, so I've still got that 65 and change in there. And so I just want to multiply that by the sine of 20. My a sub y is 22.23. And the correct direction is downward for equilibrium. That's part of the correct answer. And for the last one, we're still looking for a sub x. So our final equation of equilibrium will be another force summation. And I'll do that right up here on the top layer. Summation, round tool. Summation of forces in the x direction is equal to 0. And so I have 3 terms that I need to deal with. So I'm going to do rightward positive. So 100 rightward positive. Next term, a sub x leftward negative. B sub x leftward negative. Let's set that equal to 0. All right. Okay, doke. Notice that I did copy down that 4th sig fig because I didn't want to lose that accuracy. Won't make a big deal in this particular problem, but sometimes it does. So I'll do a negative 65.01, multiply it by cosine 20, and then add in 100. Okay, and I get a value of 38.91. So for my final answer, I'll do 38.9 newtons. And we got a positive sign in our calculation. And what that means is that we were assuming that it was leftward, and that positive sign validates it, right? So our final answer is a leftward arrow. If we had gotten a negative sign here, it would just mean that we assumed the wrong way and that the correct direction of the vector was actually rightward. I think that is it for this one. I hope this was helpful.